Hello, this is Ms. Lumley, and welcome to the Radical Functions Test Review. We are going to start with this video on number 4. And for number 4, they're asking us to find the inverse function. And I'm going to click back over to the test review, and it also says in the test review that we need to restrict the domain and range and graph the original and the inverse. So what I'm going to do here is I'm going to go ahead and write this out as it should look. Y equals the square root of x minus 2. Now remember with inverses that we want to change the y changes to x and the x changes to y. Everything else stays the same. But when we do that, we now have the official inverse equation, okay? The original equation right here in the blue is y equals the square root of x minus 2. So that means it's been shifted right to, and it looks something like this. I'm just going to sketch it, okay? So we're not going to graph all the points to it. We're just going to sketch these. Unlike the ones where you have to do them on the test, we actually have to graph and put in 3 points. Okay, so now with this one, what we're going to do here is we're going to graph this one. But we can't really graph it right now because it's not y equals. So what we're going to do is we're going to square both sides. Okay. And then that will give us x squared equals y minus 2. And I'm going to add 2 on the other side. Okay. So let me write this out and make it look nicer. So this is y equals, I'm starting with the right side actually, y equals x squared plus 2, which actually is a parabola that's been shifted up 2. Okay. However, because my original equation is supposed to be a square root graph, I don't want all of the parabola. I only want half of the parabola, okay? Because the actual mirror image of this parabola is shifted up 2 and looks like this. So I don't want the other half, okay? My answer is going to be all of this, okay? First of all, part of my answer is the original graph, which they told me to graph, and my new graph, which is the inverse, okay? The other part of my answer is the equation. This is the inverse equation to the original equation, okay? Now, the last part of my answer is going to be the restriction, okay? I don't want all of this parabola. I only want part of it. So I really only want the right side. So the domain is going to be x greater than or equal to 0. So that I don't do the left-hand side of the parabola. I only want everything on the right-hand side. And that'll give me domain x greater than or equal to 0. Okay, you can use interval notation as well if you want to do that. All right, that's how you do number 4. Let's try out the next problem. Okay, so for number 5, we're going to do this again, and that is we're going to go ahead and find the inverse. So my original equation is y equals x squared minus 3, and I'm also going to do the inverse, so it's x equals y squared minus 3. So now I have both equations. I know that the original equation is a parabola that's been shifted down 3, so I'm just going to go ahead and draw that real quick. Okay. Now for my new equation, it doesn't look quite right. I need to add the 3 on the other side, right here. Okay, and then I'll have y squared equals x plus 3. Okay, to get y by itself, I need to square root both sides, and that's going to give me y equals. Now, when you square root something, I'm saying square root, okay, you're supposed to do a plus minus, which is actually what we really want. In this case, there are no restrictions like we had on the last problem. What I'm going to do is I'm going to go I'm going to shift this left 3 because right here that means that plus 3 means the x is really equal to the opposite, which is negative 3. So I'm going to go shift this left 3. Okay? Now, this means it's a parabola, or excuse me, not a parabola, a square root function like this. And the minus is the upside down portion of the square root function. So, which will be the inverse of the parabola. See, I want the inverse of the original equation. So I want to do the top half, which is the plus, and the bottom half, which is the minus. And you'll notice that it does look like a reflection because it's reflecting across the y equals x. So it's reflecting through here. I'm a little off a little bit, but it's reflecting right through that line there. Kind of looks like a human heart. All right, so that's how you inverse a parabola and make it into a square root function, okay? So make sure that you graph your original. Make sure you graph your radical, okay, your inverse. And then right here we don't have any restrictions because we do want both halves of the parabola and the radical functions, okay? All right, so let's go ahead and go try the next one. Okay, so this is another one that is exactly the same, okay? So what we're going to do is we're going to do the first half, which is y equals. It doesn't matter what order you take this in. I could go ahead and do my first half right here. So this is my original, right? And that's what I want. This is what I need as far as the inverse. I want a whole parabola to graph when I graph the inverse. So then I'm going to switch x and y, okay? And then I'm going to subtract the 2 over on the other side. Okay, in order to do this, I have to square root both sides. So then I'm going to square root and square root. What happens when you square root something with an x? You're going to do plus minus. So it's going to give you y equals plus or minus the square root of x minus 2. So that means that I'm going to shift it right 2. Okay, the plus minus right here is the plus side is this top part, and the minus side is the bottom part. And you can see that it is a reflection of each other across the line y equals x. Remember that y equals x is the line that's kind of going through the diagonal here, diagonally through here. And that's the only thing about my little marker here. I can't get it to go straight. Okay, so again, I don't have a restriction on this. This is okay because I do want the whole thing. From the original parabola to the inverse. I want everything that it shows here. Okay? All right, just a few more problems for this video. We're going to go ahead and do these problems here. Now, I want you to notice that these are part of the non-calculator portion of the test. Okay, so what I'm doing is I'm making sure that the 27 right here is going into the root, and the root is that bottom number, the 3, and the 2 is on the outside. So for each one, my thought process is the 4 is the root, the top number of this fraction is the exponent, okay? So I put the 3 in the root, the 3 in the root, and the 4 in the root. So now all I have to do is go and evaluate all of these. So, oops, I put an X here. That's funny. Let me go erase that really fast. There we go. Okay, so now let's evaluate them. Okay, so this is 27, and the cube root of 27 is 3, and 3 squared is going to make 9. But that negative tells me that I have to inverse it, which basically is putting the 9 on the bottom of the fraction, putting 1 on top, okay? So, like, let's do this one again. So this is the answer for number 7. This one I don't have to do that with. I got a cube root of I was supposed to cube root the 8. I didn't. I messed up. Okay. Let's go ahead and fix it. This is supposed to be an 8. Look at me. Okay, so the cube root of 8 is 2. 2 squared is 4. And then I put a 4 down here. Look at me. Because that's supposed to be 27. Okay, the cube root of 27 on number 8 is 3. And 3 squared makes it 9. See? That's the way it's supposed to work. And then the 4th root of 16 is 2. And 2 cubed is 8. Okay? But remember that I've got a negative, so I have to flip that 8 to the bottom. Okay, so now you have, the answers are the one I messed up on, which is a cube root of 8, which is 1 over 4. Number 8 is the 9, and number 9 is 1 over 8. Okay, that's it for this video. Thank you so much for watching, and let me know if you have any questions.